Okay, so this is the last example for lesson number 2, proving if events are independent or dependent. So here we go. We have a survey of 57 sixth graders. The total row and the total column are already done for us. Does it appear, based on the data in this table, that the preference for social studies as a favorite subject has dependence on a student's gender? Show the analysis and explain your findings. So one of the events is going to be social studies. So I'm just going to do S for social studies. And then we have to do student's gender. So I'm going to do F for female right here. So then I'm testing if the probability of selecting a female is equal to, so again, question mark, we're trying to prove or disprove, right, this statement. The probability of F given S, right? Or I could have done as well the probability of a student preferring social studies, trying to figure out if that's equal to the probability of a student preferring social studies given the fact that they are female. Again, order doesn't matter as long as your letters are in the right spot, right? So just to review, the first letter of your given statement has to match the letter on the other side of the equation. Same thing over here. The first letter of our given statement does match the letter on the other side as well, right? So again, these are our tests to see if these events are independent or dependent. Okay, so here we go. The probability of selecting a female. Well, out of 57 students, 30 were female. And does that equal the probability of selecting a female given the fact that they prefer social studies? So again, whatever comes after given is our subgroup, which is our denominator. There's 19 students who prefer social studies. Of those 19, 10 of them are female. Right? So then I pick up my calculator and I analyze the decimals. 30 divided by 57, 10 divided by 19. Ooh, and this is a different scenario. They actually are perfectly the same. So we could say that 30 over 57 is equal to 10 over 19. So we have verified that these two events are independent of each other, meaning they do not have influence on one another occurring. Let's prove it the other way as well. The probability of selecting a student that prefers social studies, so that would be 19 out of 57 students. The probability of selecting a student who prefers social studies given the fact that they were female, right? So whatever comes after given is our subgroup. There's a total of 30 students that are female. Of those 30 students that are female, 10 prefer social studies. So again, if you analyze the decimals, once again, they come out to be exactly the same thing. So we can say 19 over 57 is in fact equal to 10 over 30, right? So we got the same, although we got different decimals in scenario 1 versus scenario 2, the outcome or conclusion is the same. The events are independent of each other. There is no influence, right? So it does ask us to explain here. So we are sort of mandated to make a sentence at least or two. So you could say, since the probability of being female equal the probability of being female given the fact that they prefer social studies. So since this is true, these two events, being female and preferring social studies, are independent events.